Thanks, everyone. Welcome to this quick lightning talk. This is the super fast tag runtime review. I'm Taylor Thomas. I am a CNCF Wasm working group co-chair. There's more about me too, but I'm not going to focus on that. We don't have enough time. So quick announcement that they've kind of asked us to do as well for some of these things. If you are involved in the ecosystem and have been involved in the tags, there is a tag reboot coming. That is something that will affect the Wasm stuff that I'm talking about in tag runtime. So multiple TOC members and everyone's going to be around in the halls and stuff if you have any questions. So with that, let's talk about Wasm. The tag runtime group asked me to kind of give an overview of Wasm and where it is. It's one of those emerging technologies out there most people have heard of. What's Wasm? This is the super fast thing. You're going to get a quick fire hose of all of this. If you don't understand it all, come talk to me later. Wasm is essentially a very small VM, you can consider it. You can build it in any language. It compiles down to a binary, and then that binary is used inside of a Wasm runtime or in browsers or whatever it might be, and those things all run on any of the supported architectures and OSs that they can run on, which is a lot. Why do we use WebAssembly? Well, it has a capability-based security model, which is just something that means you're explicitly granting it permissions to do every single thing that it can do. It's got essentially zero cold start time. It's very tiny, and I mean very tiny, and it's also portable. So those are the big main benefits there. Now, why do we use Wasm in the cloud? Once again, I said fire hose. Here's your fire hose. There is a bunch of reasons why we use Wasm in the cloud. If you look at why people first use it, which is why you've heard probably about it, is that it is very much a browser technology to start off, but it is not only for the browser. We have open standards, sandboxed, small and fast, like all those kind of things we've talked about. You're not worrying about like all the image CVEs because everything's sandboxed. You don't have a lot of dependencies contained in there. And so those are all things that we get from Wasm. Now, what I really want to talk about, because that's what everyone's here for, is the project overview. This is not everything, but I wanted to call out a couple different projects that are very Wasm focused. That I at least know well. We have a project like Hyperlight. Hyperlight is a very, very lightweight VM wrapper for those running functions and other type things where they're in very, very secure, very constrained environments. Kubewarden is a policy engine and extender for the part of the scheduling that they do a lot of stuff with Wasm as well. For their policies. You have Spin, which is a batteries included, very much geared towards the function as a service project. Those are all sandbox projects. Then we have Wasm Cloud, which is one of the projects I help maintain. That's an incubating project in the CNCF, and it is very much focused on the distributed side of WebAssembly. So you can take an application, run it pretty much anywhere, and have its dependency satisfied by connecting all these different Wasm components together. And then there's Wasm Edge, which is a specific Wasm, or another one of those battery included projects that has a lot of focus on AI right now. It's a lower level Wasm runtime. And you also have, beyond that, like I said, this is not it. Within and outside of the CNCF, you have various DBs. You have things like Envoy Wasm Proxy and all of this. If you didn't see when they were just showing the landscape, you can click the Wasm section and this pulls up. These are all the things using Wasm in some way inside of the CNCF. Most people, one of the questions I always hear is like, is Wasm real? Are people using it? Yes, people are using it. I don't know how many times I can say it, people are using it. There's lots of stuff that's evolving, and I'll talk about that in a second, but just keep that in mind. Now, in case you need it, these are some recent efforts we've done inside of the Wasm working group. One of them is we're continuing efforts on WASI Cloud, which is an effort to define various standard interfaces that are like the 80% use case. They help bootstrap people into what are called Wasm components. And on the right is something we worked on where we defined a specific format for storing Wasm artifacts within an OCI artifact. Like all the information that's stored in there. So that's something we define and is available. Those are QR codes that link you to either of those things. Now, how can you get involved, which is the most important thing? Come see us at the Project Pavilion. So the Tag Runtime booth is there. If you're going to be around for the booth crawl, we will be there. And we'll have a lot of the evening on that booth crawl with Wasm folks around. Come join our meetings. That's the QR code. You can come join the Wasm working group. It happens every other week. You can help us implement and define things like WASI Cloud. And you can also come to the Wasm working group focus talk that I'm giving with one of the other co-chairs tomorrow at noon. So we'll be talking a lot more in depth about a lot of these topics, and you can come contribute to anywhere in the Wasm ecosystem that we have out there. That can be inside of things like the runtimes or any of these projects that I mentioned. We need and want your help. So thank you very much.